So my name is Jessica Goldkind. I'm a teacher candidate in the Stanford Teacher Education Program in elementary education. When I first thought of what is there to learn about how X-rays work, I started thinking about kind of like density of certain parts of the body and why it is that bone is more dense than other things. I mean, there are so many different areas of X-ray and radiology that you could talk about in 45 minutes that we didn't even cover that very much. We mostly covered how to achieve magnification.
My name is Ram Srinivasan. I'm a neuroradiology fellow at Stanford Hospital. I was basically looking for opportunities to do community outreach to high schools or middle schools, and I saw that Splash was a program that actually brought students to Stanford. I'm actually teaching a radiology physics course right now, and so when I thought about what I wanted to teach high school students, it made sense to extend a lot of the thinking I'd been doing on teaching radiology residents about the physics of imaging to high school students to see if I could make connections with their physics background. To really understand what it meant to teach high school students was very different from what it meant to design courses for radiology residents. And my original goal out of that 45-minute segment that we're given was to empower high school students with a sense that they too could take concepts in physics and apply them to medicine to change people's lives.
The idea of backward design is to start by thinking about what you actually want the students to walk away understanding or being able to do, and then design the material based on that and the activities.
Part of the ambition of the course was to give students an experiment to play with in free-form fashion over the 45-minute period. The idea was that instead of lecturing to them, we might be able to engage them in discovery to figure out the concepts that we were trying to teach them. And at the end of the day, there was a balance between giving students guidance and allowing them to explore freely.
It's also really important to help students achieve success. And if they're going to grapple with material, I love the idea of kind of student-directed learning and exploration, but students have to have the tools necessary to actually succeed or have their struggle be productive and not just frustrating. Other things that I've learned are kind of how to facilitate group work and students being comfortable in class, which is, I think, especially important because these students don't know each other at all. This is a group that's coming together just for 45 minutes from different schools, and we are talking about the human body and breast cancer, which could be a sensitive subject for students.
Broadly, it's great to think about how we can engage students that are at the grade school level with concepts in science and medicine. And one of the important steps in going from university level teaching to grade schools is actually connecting with a teacher or a teacher in training who understands some of the principles behind how you connect with students and combining that with the technical knowledge that you bring to the subject. So that interaction, the collaboration between teachers and people at academic centers that are pushing the frontiers of science is really essential to engage students and get them interested.